Hello and welcome to the monthly Southwest Drought Briefing. I'm Emily Elias, Director of the USDA Southwest Climate Hub. These monthly briefings emerged during the 2020 Southwest Drought from the Monitoring and Impact Reporting team of the Southwest Drought Learning Network, or DLN. The DLN links climate service providers with resource managers and resource managers with one another to increase landscape and community resilience in current and future drought. These briefings will continue as long as there are areas of extreme or exceptional drought in the southwestern United States. We begin this webinar by respectfully acknowledging that the land we are joining from today is the ancestral land of Indigenous peoples. As we are in different parts of the country, this will be different for each of us. The land where I'm speaking from is the ancestral land of the Nuchu or Ute, and connected to the communal and ceremonial spaces of the Apache, the Pueblos, Hopi, and the Dene Nation. I believe it's important to provide this acknowledgement because the narratives of this land and region are often told without acknowledging our history. Thanks for your attention and respect of this legacy. I want to also take a moment to thank my colleague, Joel Lisenby. Joel is the Drought Early Warning System Coordinator for the Intermountain West and Southern Plains regions at NIDIS, or the National Integrated Drought Information System. Joel will be moderating the questions at the end of the briefing, so please use the question feature at any time during the talks. Following this briefing, a recording will be available online at drought.gov. Today we will hear from two presenters, both from Arizona. Dr. Erin Safel will present our current climate conditions and outlook. She is Arizona's state climatologist, director of the Arizona State Climate Office, and senior global futures scientist with the Julie Ann Wrigley Global Futures Laboratory at Arizona State University. Following Dr. Safel's presentation, we will hear about co-developing the Drought Severity Evaluation Tool for use on the Navajo Nation, presented by Nikki Ray Tully, doctoral candidate at the University of Arizona. Nikki Tully is a member of the Navajo Nation. She has worked on the Drought Severity Evaluation Tool team alongside members from NASA's Western Water Application Office, Desert Research Institute, and the Navajo Nation Water Management Branch. She is a team member of NASA's Indigenous Peoples Initiative. With that, I'll turn it over to Dr. Safel for the climate conditions outlook and update.
Thank you very much. I appreciate this opportunity to talk with everyone, and hopefully we've got the technology going correctly and we can go from there. If I could just get confirmation that you can see my slides.
Yes, they look great. And you're
Thank you very much. I appreciate that. And so thank you for this opportunity. I'm going to do a brief discussion on what's been going on with drought in the Southwest. And we're going to start with some really great numbers when we're looking at the last 30 days, when we're looking at the precipitation. And of course, on the right-hand side of the screen, you're looking at the percent of average precipitation over the last 30 days. And there's a lot of those good colors when we look at these kinds of maps. So we're seeing 200, 400 and above percent of average precipitation here in the West. And you can see that Nevada and Utah, Colorado, Arizona, and portions of New Mexico all have benefited in the last 30 days. On the left-hand side of the screen, you're looking at the average temperature, the departure from average over the last 30 days. Fortunately, not seeing too many of those oranges and reds here in the Southwest. Those would show us that we're warmer than average. So it looks to be just average to slightly above average in most locations here in the Southwest. That becomes important. We're very interested in the temperatures because that affects the evapotranspiration areas. And so looking at what was forecasted for January, so this was released at the end of December last year, and looking at that forecast, it seems to actually have verified fairly well so far, looking at what's been going on in the Southwest. So Arizona really is in a lot of areas without measures of drought or just abnormally dry, which is also no drought. And you can see Colorado and New Mexico doing those same kinds of areas that are in the white map area, which are improvement. So we're seeing a lot of that, and it actually verified to what we see. If we go to the next slide, you'll see that improvement. So I pulled up a couple of those maps showing at the end of December, before we had a lot of those atmospheric rivers coming in, and we're seeing December 20th map versus our current map, and really looking good. No more exceptional drought, except for a little bit in Utah and Colorado, and the entrenched areas, extreme drought in Nevada and Utah, those kinds of things. Oh, I'm sorry, excuse me, there it is. A little bit of the exceptional drought in New Mexico. So everything's looking much improved. If we're looking at Arizona, areas with no drought, so that white area of the map, they doubled from what we saw at the end of December. So that's a great, huge spread in central Arizona, and we're seeing a good spread in western Colorado as well. It's interesting to go back a year and to see where we were a year from this date. And you can see here that the Southwest was really involved in largely severe drought, moderate drought. Arizona had benefited. We'd had a really wet December in 2021. And so we had a lot of abnormally dry areas that were spreading. But you can see most of the rest of our states in the Southwest really were entrenched in that severe and moderate drought, a lot of extreme drought, and Nevada, of course, a large amount of exceptional drought. And then one thing to consider, so last January, a year ago, we were dealing with our winter precipitation, and then we dried out. Most states in the Southwest really had dry conditions through the rest of the winter and spring. Arizona had the driest April and May on record with no measurable precipitation. And so you can see that the drought levels started to increase. New Mexico having that exceptional drought. Nevada had the exceptional drought expand a little bit in Utah. And then we had our 2022 monsoon, which came in and actually mitigated a lot of drought levels. And so this was at the end of the water year, looking at how Arizona had improved, a lot of abnormally dry, Colorado had improved, New Mexico, much improvement. And so we're seeing there a great change through a nice moist summer. The fall has been fairly wet in Arizona, and then we had those 9 atmospheric rivers that came into California in the last 3 weeks. So when we're looking at the snow water equivalent, when we're looking at our basins, we're looking at where we are from the median levels. And you can see that a lot of areas in Nevada, Utah, Arizona, very good with our snow water equivalent. We're at over 200%. When we're looking at California, the Great Basin, both of those are over 200%. The upper basin, so that includes what we're looking at with Colorado and Wyoming. The upper basin of Colorado is about 146% of median, and the lower Colorado River Basin, largely Arizona, a little bit of New Mexico, we're at 217% of median. These are current numbers that we're looking at. So we're happy to see that snow water. We're hopeful that it maintains. We do understand that things can change. An aspect of understanding our runoff efficiencies is looking at our soil moisture. So this is the last 30 days soil moisture percentages, and those give us a good sign that our soil moisture is going to allow for that runoff efficiently as we move to our peak melting time. So typically in Arizona, we're dealing with our peak melting time in March. Colorado, it's typically closer to April, May. And so we're happy to see these kinds of things, allowing us to kind of hold on to some of that water that we've been receiving. The reservoirs right now, most reservoirs still below average. When we're looking at, of course, Lake Mead and Lake Powell, those are dealing with a lot of issues that are largely entrenched. If we're looking at Arizona reservoirs, they're doing better. And so when we look at the lower Colorado River Basin, particularly in Arizona, the Little Colorado River and the Lake Mead basins will drain. They'll drain downstream from Lake Powell, but they may have some impact on what happens with Lake Mead. We're hopeful for that. In Arizona, we have a main system in central Arizona, the Salton Verde River system, and that's about 77% full as of today, and that's about 6% greater than last year at this time. So we're seeing some good things in Arizona as well. So then looking at the seasonal drought outlook, it was just released a few days ago, looking at what we can expect to happen through April. And looking at where drought persists, we have Nevada and Utah drought persisting, hopefully remaining the same in Arizona, not advancing. Some development in New Mexico is expected, but we will see what happens as we progress and go through. Other aspects, looking at just the next few days, so the 6 to 10 short-term forecast, possibly colder, possibly wetter. We'll have to see how that verifies. Definitely much colder right now. We had a really cold core system through Arizona, and we're fairly cold right now. In Phoenix, we're in the 40s in the middle of the day, so very, very cold. And that's happening because we've got some cold air that's just coming down off of that ridge. This is what we're seeing with our 500 millibar heights, and you can see out in the Pacific, you can see that there's another trough, so we may have another system possible, and that may give us some precipitation. We'll have to wait and see, but that's kind of what's going on at those upper levels. And then just something to end with, I had some questions about wildflower season, and that usually starts peaking in February and March in Arizona. And so looking at precipitation from the start of the water year, so from last October, November, it's a good thing. We're seeing a lot of precipitation in Arizona, and having that higher soil moisture really does help our wildflower season. So everyone's looking forward to that. I'm very sorry if anyone has allergies, because that might increase as well. I think we're going to take questions later on. So I'll go ahead and end, and thank you for your time. I appreciate that.
Excellent update, Dr. Saffel. Thank you so much. And we will hold for questions, although you can enter your questions at any time into the questions box in GoToWebinar. So now we'll turn it over to Nikki Tully, doctoral candidate at the University of Arizona, to hear more about the project that she's working on around a drought severity evaluation tool. Nikki.
Thank you. And could you confirm with me also that you see the PowerPoint in full presentation mode?
I do, yeah, it looks great.
All right, thank you. So yeah, today everyone, my name is Nikki Tully, and I'm a member of the Navajo Nation and also a doctoral candidate at the University of Arizona, and have had the opportunity over the past few years to work with NASA and several other entities on this drought severity evaluation tool, which I will present to you today, looking at this Earth observation of the collaboration with the Navajo Nation As you can see here on this intro slide, there are a number of project team members, Amber McCollum, Carl McClellan, Justin Huntington, and Britta Dowdert. These are members from different entities that have worked on the project with Berry NASA Ames Research Center, the Navajo Nation Department of Water Resources, and the Desert Research Institute. So I wanted to start off in starting and sharing this presentation with you to give you a Landsat view. This is the first light image from Landsat 9 that was recently launched about maybe a year and a half ago of the Navajo Nation, to give you an idea of what a lot of the landscapes of the Navajo Nation looks like. The Navajo Nation is comprised of over 27,000 square miles, and a lot of that landscape is a semi-arid region. And in connecting what the view from the sky looks like with the satellite nature, I also wanted to share with you this background of what has led to this co-development of this particular tool. And so this is some photos that I have from the Navajo Nation. And I'm part of a group, the NASA Indigenous Peoples Initiative, with the capacity building applied science sector of NASA. And with this group of people that I am a part of a team with, this on the left-hand side of the schematic that you see of community engagement, place-based approaches, technical workshops, and the inclusion and understanding of Indigenous knowledge system is something that is really relevant to us and something that went into the development of DSET. And so understanding that community is really a big component of the data use, it was really important to us to see how we can understand Navajo and understand how the connections of Earth observations, and in this particular case, the Earth observations related to drought would connect. And so some of these pictures at the top there are meant to show you what some of the important characteristics that you'll find on Navajo, that being livestock, agriculture, some of the landscapes, noting that a large population on Navajo still haul water. And in developing this understanding of community and co-development collaboration with the partners that worked on this project, there was a video that came out, and this is a video that you can find on YouTube or with the website with DSET, that gives the introductory in the Navajo language of understanding the form and way Navajo is expressing drought in the Navajo language and looking at the landscapes and moving into discussing what the tool could do. So I showed you what it looks like from the satellite view of describing to you briefly with that Landsat image of what 27,000 square miles looks like on Navajo. These are some views from the ground of what the landscape looks like. So you can see again that this is a very semi-arid nature, but also there's a lot of different identities of sand dune migration that you might see. There's rural population of where homes are located. As I mentioned, livestock and agriculture being a big component, and water hauling being a component of life as well on Navajo. And then also recognizing the impacts and differences that legacy waste has continuously had on Navajo over the years. And so understanding that there's different ways of looking at Navajo and the landscapes, DSET took to look at one aspect, and that was drought. And so these are some pictures to show you a bit of what the drought impacts on Navajo look like at different times during the year. And so this was just about in the months of last year, in the months of June and July, of some of the images that you might see on the landscapes being taken in Western Navajo, on the western side of Navajo, on the Arizona section of Navajo. As you may know, that Arizona is one of two states that the Navajo Nation lies in, the other being Utah and New Mexico. And again, showing you the intensity of the dust storms that are being experienced on Navajo and the different types of impacts that are being related to everyday life. And some of those I shared with you in the previous slides through some photos of what some of the residents and some of the everyday tasks might entail and what they face during these types of drought impacts. And so understanding that drought is a major impact on Navajo, there was this concept and idea of how can we bring the ways of knowing together. And this is where that collaboration came together through this funded NASA Western Water Applications Office project that was co-developed with the Navajo Nation Division, the Department of Water Resources, and the Desert Research Institute. And so in these discussions of collaboration, in understanding that the biggest outcome of this tool would be this user-centric tool. And so that we know that when we're looking at Earth observations, things can become very technical in doing remote sensing spatial analysis, but understanding that this tool would be highly aimed at being user-centric, there's some key points that came out of those discussions with these groups of people and understanding how DSET would be developed. One, that the tool would aim to be a free web application. Two, that it would be user-friendly. And so really understanding the technical I guess, analysis of drought would not remain at that high level of being technical, but making it user-centered for people such as decision makers, community members, and so forth. Tribal employees could be able to access and use this tool. The third point being that time and storage saver. Anybody that works with Earth observation can tell you quite quickly of the storage it takes, but also the time to work through a lot of these types of data sets. And then lastly, to make the analyzing and the visualizing of the data made easier. And so these were 4 big points that came out of this discussions for in collaborating in this aspect of tool development. And so what came about from these discussions and these understandings of how to make this tool user-centric for primarily for this monitoring of drought is that DSET was created, and it was created as a spin-off of a climate engine. And there's 3 components to this spin-off that went into this spin-off to develop DSET. One is that the Navajo Nation would contribute some ground-based data in the form of Navajo rain gauge data, and that's the photo at the top left that you see there. There would also be the inclusion of the satellite data, which comes in the form of NASA data, and also that there would be these model inputs that the Desert Research Institute had really helped with as well. And so these 3 tools coming together in the form and analysis coming in the form of DSET was really to look at how can we create drought reports to be able to help in monitoring drought. And so here at the bottom center screen, you'll see a screenshot of the Drought Severity Evaluation Tool. And some of the visualizing of data on the map aspect of what DSET can do is looking at remote sensing, but also climate and hydrology. Some of the data sets that you'll find within DSET is GridMet, CHIRPS, MODIS, and Landsat are some of the remote sensing, Sentinel. And some of the variables that are able to be looked at is the NDVI, the SPI, and others. And one of the key features in developing the spinoff of a climate engine for the Navajo Nation for this drought severity evaluation tool was the inclusion of the administrative boundaries to be able to be used to create further analysis specific to areas of Navajo. As I mentioned earlier, that the Navajo Nation is 27,000 square miles, and in that 27,000 square miles, there's 110 communities and 5 agencies. And so with this type of focus on looking at the scale, there's opportunity to have more in-depth understanding of what is happening on the Navajo Nation with the data sets and forms of analysis available in DSET to help create this enhanced understanding of what is being experienced in the area of drought on Navajo, as well as some of the other variables that are able to be looked at with the data sets. And lastly, I wanted to show you this, and this is a screenshot today from DSET looking at the last 30-day SPI. Over these past few weeks, Navajo has been getting a lot of snow, and so it's captured here in a bit of a closer view to show you those administrative boundaries looking at the standardized precipitation index. And as you can see in the previous slide, looking at a 5-year SPI, you can see that it's an exceptional drought. And you can look at now the different scale in the 30-day SPI of anything ranging from exceptional wet to abnormal wet, in looking at being able to provide data specific to the Navajo Nation in the area of drought. And so this is what I would like to share with you today, and thank you for being here.
Great, thank you so much for that, Nikki and Aaron. This is Joel Lisenby here from NIDIS. I'm going to be moderating the questions as they come in. If any of you attending would like to ask some questions, go ahead and put them into the questions box. We only have just a little under 10 minutes left. We probably won't have time to get to all of the questions, but if you have questions, go ahead and put them in. I'd also like to point your attention to the chat box where there are some links to some of the resources that Nikki shared that you can go and check out a little bit more on your own. So the first question that I'm going to ask is for you, Aaron. A question from George about what are some of the errors around the snow water equivalent estimates? If you would like to talk through how we get that data and how we should understand it, that would be great.
Yeah, no, I'm happy to talk about the SWE, the snow water equivalent. It's one of those terms that's it's odd, it's hard to understand, but that's how we measure what's going on with our snowpack. So with snow water equivalent, some of the issues that we deal with are looking at the amount of water that would be in that snowpack, the average amount. So we use a ratio for SWE, and you can typically pop into a 10-to-1 ratio. So that means that for every 10 inches of snow, it would melt down into 1 inch of water. Now that's an average, and it's probably not as effective as to what's really going on for the different snow events that land on the snowpack. So you probably have heard of dry snow. You probably have heard of wet snow. So with a dry snow event, you can have maybe 20 inches that you have to melt down before you get an inch of water out of it. And with a wet event, maybe you have about 5 inches that you melt down that can be an inch of water. So that's one of the variables that we have to take into account when we're looking at our SWE or our snow water equivalent.
Thanks for that, Aaron. So does that mean that in some places there's, like especially in the mountains, they're measuring the density of the snow, like so that we can get an idea of how much that would, the depth would equate to
right,
water?
That's a good question. So we have a lot of instruments that are automated in what's called a SNOTEL, SNOTEL, an automated mesonet. And the way that those SNOTEL weather stations operate typically is using a snow pillow. So it is measuring the weight of the snow, essentially, to give us a sense as to the pack for the snow. So that can be done automated.
Great. I'm going to have read the next question for Nikki. Nikki, if you're there, I think some of us are a little surprised to see that there's still water hauling in the Navajo Nation. What are the sources of some of that water? And I think there was also a question, so I'm sort of merging a few questions here. There was a question about how much of the Colorado River water is able to be used in the Navajo Nation for consumptive use.
Yeah, so I don't know about the Colorado River statistics of consumptive use, but to give you, I guess, like a little bit of insight to water hauling. So water hauling on the Navajo Nation in different various reports will estimate anything from 15 to 30% of the population of Navajo Nation that still hauls water. A big part of the where people obtain their water from is definitely the groundwater that we do have on Navajo. There are a number of permanent watering points that are established. And then in the time of the pandemic, there has been the establishment of some temporary watering points. So people tend to go to those areas to obtain their water, and that's either for agriculture, home use, livestock. It just depends on the particular water hauler user themselves. People also will travel off reservation to get water. As you know, that there's also natural springs in the areas, and so it definitely just depends on the user, but definitely the groundwater is the primary source.
Great, thanks for that, Nikki. The next question, I'm going to go back to you, Aaron. It's a question from Rachel, who she says she's with CNN. The question is around the improvements that we've seen in the recent snowpack, or from the recent snowpack, and especially in parts of the Colorado River Basin. As mentioned, it's running above average. But do we know how many more storms like this, and I might add how many more seasons like this, will we need to make up for years-long deficit along the Colorado River? I'll leave it at that. I'll let you answer just that part of the question.
Right, thanks, Joel. Yeah, no, I'm happy to answer the questions. It's a challenge when we're looking at, a nice wet season, and it looks great right now. But if we go back, especially in Arizona, we can go back to 1994 and look at our water years from that period of time. And we've only had 9 wet years and 20 dry years. And so there's a huge deficit that has to be made up. And this isn't just in Arizona, it's in the Southwest. And so it does take a little bit more than one wet season. We're excited to have a wet season. We're happy for it. I'm thrilled that we had a wet monsoon season last year, and it kind of continued to be wet through fall, and it's looking really great right now. But at any point, that spigot can shut off, and we need to be mindful of that it's going to take a little bit longer than just one wet season or one wet year before we really move out of this entrenched drought.
Thanks, Aaron. It's interesting to look at like how much water we were all very excited about the monsoon during the summer. It was a great monsoon, and now we're having this great winter. Can you just quickly talk about how much water we're getting during the winter, these winter storms, compared to how much we got during the summer?
So when we're looking at our precipitation, summer versus winter, it's a different kind of structure. We're getting liquid precipitation in the summer, and the type of thunderstorms that we have in the summer, they're convective thunderstorms is what they're called, and that brings us that really heavy, intense precipitation in a short period of time in a very isolated location. And so really the summer precipitation doesn't really go into our water supply. We're really excited to see the snowpack. We really rely a lot on the snowpack, the winter precipitation, to recharge our aquifers and to move into our reservoirs. So that's that's kind of the big distinction between summer precipitation and winter precipitation.
Thanks, Aaron. We have time for just one more quick question. This one's going to be for you, Nikki. So are there areas in the Navajo Nation that may face potential hazards from this snow melt, and are there adequate storage systems to capture that snow melt and runoff?
So there are areas on Navajo right now who are experiencing some emergency declarations, and so as far as the holding of snow melt in reservoirs, I'm not too sure about that. But my area of focus currently is working with communities, and so some of those communities are in areas of needing assistance, and so through some of the photos that you may see. It's very rural, and so as the road conditions are some of the difficult times that are being focused on right now for transportation in ways of, like I mentioned, there's a large population of Navajo who still haul water, and so it's looking at different areas of impact with rain, with snow, with drought, that I feel that Navajo has to consider when looking at these types of events.
Thanks, Nikki. So I'm going to wrap it up there. I'd like to thank our two presenters, Dr. Erin Saffel and soon to be Dr. Nikki Tully. I'd also like to thank Emily Elias from the Southwest Climate Hub for welcoming us and hosting this meeting today. And thank all of you for joining us. Our next Southwest Drought briefing is scheduled for February 21st at 1 p.m. And we look forward to seeing you then. Thanks, everyone. Goodbye.